Time to start.
All right. Let's go. Day 8. I swear, every time I look at the video afterwards, the VOD, my sound is whack. I'm tweaking it constantly. Let me know if it don't sound no good. Let me hide this. Share that. All right. Advent code. Day 8. Let me zoom in. Okay, the historian's doing their thing. We have a huge antenna. To your surprise, it seems like it's been configured to emit a signal. Scanning the city. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map, your puzzle input of the antennas. Okay, lowercase letter, uppercase letter, or digit. Got it? Okay. The signal only applies its nefarious effect at specific antinodes based on the resonant frequencies of the antenna. In particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when the antenna is twice as far away as the others. Okay. This means that for any pair of antennas with the same frequency, there are two antinodes on either side of them. So, for these two antinodes with frequency lowercase a, which is different from uppercase a, yeah, they create two antinodes marked with pound. Okay, the signal only applies at specific antinodes. An antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far away as the other. I don't really know what that means. I'm going to keep reading. But only when one of the antennas is twice as far away as the other. What does that mean? I don't know. With the same frequency, there are two antinodes on either side of them. So for two antennas with frequency A, they create two antinodes. Okay, adding a third creates several more antinodes. Boom, boom, here. Boom, boom, here. But two are off to the right side of the map. Okay. Okay, so you can't go off the map, but there are two, one here and one down here. Okay. And I don't know what that sentence means, but it seems like antinodes happen on either side, equidistant from, with the same distance as this. Something like that? Okay, antennas with different frequencies don't create antinodes. A and A count as different frequencies. However, antinodes can occur at locations that contain antennas. Okay? In this diagram, the lone antenna with frequency capital A creates no antinodes, but has a lowercase a frequency antinode at its location. Yeah, we just saw that up here. Yep, okay. The first example has antennas with two different frequencies, so the antinodes they create look like this. Plus an antinode overlapping the topmost A frequency antenna. Okay, so this one has an antinode on it, but then you have this and this with those antinodes. We don't have any vertically or horizontally aligned, which is interesting. Okay, but these two, yeah, this is the antinode there. That one's off the map. Okay, so it doesn't seem to matter how far away it is, just if they're in a line. If they're in a line. Well, yeah, that's these two. But there is one here, there. So there would be one like up here. Okay. Because the topmost A frequency overlaps with the 0 frequency, there are 14 total unique locations that contain an antinode within the bounds of the map. How many unique locations within the bounds of the map contain an antinode? Let's see what our input looks like real quick. Okay, not insane. Not insane. Triple click, boom. Pro tip. All right. Day 8. Day 8. Zoom in. Want everyone to be able to see. Comment T. Don't forget our comment block. Def in, def T is blah. And let's just go ahead and parse the board. Stir split lines into, we're just going to do the thing where we know X is Y and Y is X. Feck, feel like is it? Oh. Okay. Ba-ba-ba-da-ba. Yep, this looks approximately correct. All right. Util, so there is, and that's not it. There's taxi cab difference, but then there's distance, right? Which is close. The distance between 1.1 and 0.2. Erect points, taxi line points. So I'm looking for, we have a line that is not a taxi cab line, right? Not a taxi cab traversal. Taxi cab on a grid, right, only goes up and down like this. It looks like we're mostly looking at diagonals, maybe entirely looking at diagonals. It would be nice if they only did diagonals. I mean, offhand, I'm not seeing anything that lines up on the same horizontal or vertical line. So if we only have to look at diagonals, we have to get... What do? We go to a signal. This is not going to be fast, but we look around the whole board for other signals. Say, hey, this is this far away from that. That far away on that line is blah, right? There's a slope of this line from here to here. On that line will be some other point, blah. That's an antinode. Right, and we just do that. We keep a set of all antinode locations. And we do that for every signal that we can find. Right? I think that's it. I mean, it's the brute force method once again. I'm sure, I don't know. By the way, chat, I made a Hall of Fame. What? I thought I did. Yeah, Wall of Fame. Airdos might have like a brilliant way of doing this, but I can only think of the brute force. Just march through it. Look at all the frequencies. Find all the other frequencies. Get the slope of the line there, and then the distance, and then add that distance to both sides. Right? We already have a distance function. The absolute value of x, the difference of the x's over 2 and the difference of the y's over 2. It's a standard geometry definition. I guess, yeah, we could do slope. Do we need slope? Do we have to do the geometry thing? I think so. Can't believe slope is not in here already. Let's just do this. I don't think it needs to be too fast. Slope for 2 points is it's rise over run, right? And the rise is going to be y2 less y1. And the run will be x2 less x1. I think. If memory serves, it's been like, I don't know, 30 years since I've used that equation. Yeah, let's just start doing something. Let's see. Well, hang on. We'll put the board in here. And we want to rect points. We just want to go over all the points in the board. Reduce. Maybe transduce, we'll see. With an empty set, so these are all of what we've seen. And a point P. This is going to be slow. This is going to be slow. But we all know my MO at this point, right? Slow is okay. Now we don't need to know duplicates, right? Yeah, unique locations. So if for some reason this has already been done, or unseen is a bad word. What are these called? Antinodes. If it's already an antinode, then we just return antinodes. Otherwise, we do the fun thing where we, I guess, I mean, we could do an optimization, an easy optimization here is to do a single pass over all the points that have, like, you would make a hash map, you would cache, right, the hash map of all the A points. So it'd be a hash map. It'd be a hash map of like A right here, and then the set of all the points that occurs, right? That is an optimization that we would be able to use right here. We do it at the start and then use it here. That seems reasonable to use. Instead of walking the board every single time you find a point. This is a dumb optimization that we can definitely do. So we'll walk all the board instead of trading memory for time, right? Instead of walking the board, I don't know, however many number of this, right, of letters you see, not letters and numbers, we're going to walk it once and then look in a hash map. I think that'll be a good optimization. So B, and then we'll have, what are they called? Antennas? Antennas are going to be util rect points of B into, we can do it direct into, because we're not needing to keep state, we just need a list of all of the points that are not dot, basically. Keep. We'll just do a filter. Oh, no. Keep when not equal to dot. Get in board P. Then return, well, we need to let that, right? We need that twice. Let the value is that, blah. V, wait, ooh, I lied. We do want reduce. Transduce. Because we can use this keep. This keep is fine. But we do need to do this, right? VP. And then completing accumulator V and P. Update in accumulator V update just update, not update in fnil conj fnil what conj P, right? So this should give us that this looking thing. Hopefully, let's see. Okay, 0. Oh, we need to initialize it with a hash map. FYI, you know that I knew that this is the problem from this. This doesn't look intuitive. This is one of those things you learn in Clojure. I hear a lot that Clojure has like terrible error handling, error messages or whatever. But like you saw right there, I knew exactly what to do with this. Right? This is not hard. You just learn over time. Hey, wrong number of args when you're doing a transduction. It's passing 0 args to this because I didn't initialize it. That's how transduce works. That's how reduce works, by the way. If you don't initialize it, it calls this function with 0 args to see what you want as the initial value, because you have to tell it somehow, right? And yeah, so this is just a standard error that you find. You're doing transduction, it's doing this, you need to initialize it with that, right? I think, let's see. Boom. All right, and we, like I said, we have the hash map of this character to all the places that that character happens, right? Beautiful. Now we could say, hey, we could just bring the A's on board here. Antennas. Huh? Okay. Chat is very quiet today. Very quiet, chat. That's okay. We're still getting the swing of the week. It's only Tuesday. We're not even really spun up yet. You know what I'm saying? All right. If it's not an antinode. Wait. Oh, this is cool. We don't even have to go over all the rect points. We don't have to look around the whole grid. We can just go over all the antennas, right? That's right, Vapid Babble. Only Tuesday. We can go over all the antennas. We don't have to go over the whole board. Okay. Oh. Plus, avoiding the temptation to backseat. Plus, I'm trying to get my part too. Oh, it's a race. It's a race in paren. Let's go. Okay. Now I have to go fast. Wait, what's right here? We have point and wait, no, the frequency and the point. And we're looking for our antinodes, right? If antinodes, right, this is still the case, like it might already be an antinode. Otherwise, we need to go over all of the remaining antinodes. So we want to disjoin hang on. Yeah, I think. Yeah, disjoin from antennas. I need that not as antennas. Ants. Why not? Disjoin from the ants this frequency. Wait, no. I get get from the ants this frequency. Oh, that's right. Yeah, and then disjoin P from that, right? We don't want P in that set anymore. Take that out. We need to look over the remaining points. I'm winging it, team. My hands are guiding me. Jesus has the wheel here. We get, let's say we're at 2.5. We're getting these out. Wait. This isn't quite right. We want to kind of map cat. Transduce. Completing map cat. This will be the char. Wait, no, the frequency and the points. Right, and we want to go over all of the freak points individually, right? So map over the points. This is a slick way to do this, right? I think I'll do it. And let's see. By the way, InPrint, you're allowed to backseat on this stream. This is not a Tim solves it kind of thing. Yesterday, Clojure guy was, or Alec was the one that basically solved all my problems. It was awesome. We'll just put those there in a second. Ants. I can't even. Boom. Can't be bothered. Parse T. I just want to make sure this does what I think it does. Oh my goodness, into... My typing is like really painful today. Ants. So this creates a sequence of like this is here and this is here and this is here and this is here. Correct? Because we need to look at each of these individually and then we're going to look them back up. In theory, we could tack this in there too to avoid one more lookup. That's getting a little wild. Right, so like we have all the information you need for this whole operation in one thing. I mean, that's not bad though, right? That's kind of okay. Points, right? Okay, so we want to take P out of points. Now we don't have to look up again. Take P out of the points. I mean, heck, we could do this, right? Disjoin points P. Now we just look up points. Oh, wait. I lied. Yeah, we're here. Disjoin P out of the points. And then here's the thing. So, I don't know, filter or something, right? We know all of the locations of this. We need to get the slope. Do we have to do the geometry thing? Yeah, bless. This is P prime, right? Let slope is slope P and P prime. Because we need the slope and the minus slope. I don't think we need a filter here. We want like a map cat. We have a slope and a minus slope. And then we have a distance. P and P prime. Wait. Y equals mx plus b. What we need is you never use distance in paren. I don't want to use distance. My poor brain hasn't done geometry and I don't know, I guess since the last advent of code, if I'm being honest. What's another way? Oh. Wait, can you... I mean, it's kind of distance E, right? But can you just take the difference in the X's and the Y's and then add it to both sides? Does that work? Does that do what the thing says? Right, so for this one, somebody used complex numbers for one of the grids. Can't remember who. Dude, okay, side story. I may not finish today, but we'll see. Side story. Complex numbers are completely baller. Complex numbers. You get to see my whole history. Hopefully it's nothing crazy. Wait. I want to look through my history for complex numbers. Oh no. Imaginary numbers. Imaginary numbers. Yeah, imaginary numbers are real. Dude, okay.
Let's say we're
everyone needs to watch. As soon as this stream is over, go and watch this entire series, Imaginary Numbers Are Real, starting with part 1. It will blow your mind. It is incredible. I have always thought that imaginary numbers are like just math people's, fantasies, and they happen to be useful in physics. Like I knew things about them and I could use them. But this is the first time I've seen a really compelling argument for they exist for real. Like they just badly named, and we need them, right? It's not a matter of like, it's like negative numbers, right? Negative numbers do exist, right? We all agree on that. Anyways, excellent series. Highly recommend everyone go do it. I wish I could use them right here, but I don't know how. Is it part 2 you said? One of the grids, can't remember. Yeah, maybe. Okay, sorry. Back to the point. I think it's possible. So if we take these 2 points right here, right? I did that too. I don't know why I'm looking over there. If I take these 2 points right here, we'll just do A. Point B. Yeah, it was kind of pejorative. It was. He tells you in the series who invented it. You would know his name, but I'm not gonna malign somebody accidentally. But it was kind of pejorative because it was like, I don't know, they thought what I thought, right? It was like, hey, is the mathematicians just, self-gratification, But they're legit. Like you should use them. X1, Y1. And there's good evidence that it's actually there's good evidence that it's actually real. Like you see them in nature when it comes to quantum mechanics. Okay. So I am suggesting that perhaps you can get them by saying, look, take the difference. Look what you can do. Delta X is the difference in X1, X2. If the antipole is 2x away in the direction of the other antipole, that makes the other antipole the midpoint. Use the midpoint. I'm so slow sometimes. Often. I think often is a better term. So adding a slope is what I did. Is there a way to say, given a midpoint, find the... I don't want the... well, if there's an equation for it. I don't know. Wait, so adding a slope is what I did. Adding a slope. Right. Hang on. Slope. Right. Take the slope. Slope is rise over run. Right? So if I add the slope to the y, that'll tell you the rise. But then you need... wait. Oh my god. My brain. If I add the slope to the y, but no, you have to multiply by x, right? To get the... oh my god, my brain. So adding a slope is what I did. Makes the other antipole the endpoint. I need another cup of coffee. So, what do we have? Y equals mx plus b, right? You're right, I named it wrong. I added the difference. Right, yeah, no, that's kind of the direction I was going. Okay. Right. And then delta y is the difference in y2, y1, y2. I don't know. I don't know if it matters which order I do it in. And so what you would want is x... what? x1... ooh, you do have to get the direction correct. I think we should be good. x1 delta x. I feel like there's a way to do like a proper delta sign. I don't know. y1 delta y. And then the subtract x2. I might have gotten these wrong. Might have to switch them around. y2 delta y. Right. So is there a 0 at 3, 2? And I think I have to go backward, like 1, 2, 3, 1, 2. No, 1, 2, 3, 1, 2. No, wait, it goes the same. Wait, 1, 0, 1, 2, 3, 0, 1, 2. 0, 1, 2, 3, 0, 1, 2. Okay, there is one right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, did I get it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There was definitely a faster way to do that. But I think we got it. I think this returned the 2, but for these 2 points, 2, 5, and 1, 8. 1, 8, 0, 1, 2, 5. It was boom and boom. Yeah, we're good. Boy, I didn't have to do real math after all. I think. Yeah, we could abstract this out, but I don't think so. Let's just return the antipoles this way. So this is x1, y1 here, and p. Okay, we're gonna have to swap those around. Px, py. So we're at point SP. And this is Gaming Sasha 99. Welcome to the show. You're coming in just in time to see me struggle. PX less X1. Oh, let's just do X. PY less Y. It's a struggle train this morning. Gaming Sasha 99. I got like geometry problems. And I haven't taken geometry in a bajillion years. PX, PY, and then X and Y. Okay. How was my day? My day's good. Day is good. It'd be better if I didn't have to do geometry, but you know, I opted into this. So my wife said, I told her I was busy, really busy recently, and she's like, I have no sympathy for you. You chose to stream, right? That's fair. I feel like that's fair. Okay, so this gets us all the antinodes. We want to remove the ones that are off the board. Remove removed all the ones where no, I streamed this just during Advent of Code for like an hour. So far it's been an hour, maybe hour and a half a day. So not a ton. But it is during work hours, so it is like you know, it adds to my day. I got like regular work to do after this, and then, you know, everything I'm not doing right now is getting put off. I work for a retail company, so this time of year is extremely busy for us. That's just the way it goes. I'm a full-time, I am the director of technology for Simple Modern company. I'm not sponsored by them, by the way, so I don't speak for them, but I do, you know, I manage their accounting systems and their technical systems, their hookups with their 3PL partners is what they're called. Warehouses is another word for it. So very busy time for me right now. Everything is slowly breaking because that is the way of the world, you know? So either those are negative off the top and the left of the board, or, gotta get this right, count first of B. X is, X is greater than the count of the first of B. Or, wait. And this needs to be Y, I think. Again, it's Y, X are the point systems that I'm working with. I also watch streams just in free time. Other than that, I do my work. Yeah, I'm streaming during work hours, quite technically, but you know, it's only Advent of Code one time a year. I feel this is the also. Well, here's the thing. Here's the real deal. I have kids, right? So if I try to stream at, I don't know, 8 o'clock at night, you know, my son's bedroom is right through that wall. You hear me yelling at the microphone constantly. was the person for... Oh. Triple star. Was the person for future reference? Can you not say names? So yeah, if my kids are sleeping, they'll hear me yelling. I can't talk full volume. If I try and do it at like 6 while they're awake, it'll be a stream with my kids. That's it. They aren't going to leave me alone for an hour or whatever. How many kids do you have? I have 2. I have a son and a daughter. Gaming Sasha with all the questions. I love it. I love it. Okay. This right now, as it is... Wait, what is this going to do? Ellis Kinyo. Who's Ellis Kinyo? Is that who discovered complex numbers? Juxt. Wait. I missed something. I don't know. I don't know how Ellis Kinyo came. I missed something. But Ellis is apparently in the community? Emacs, sir? Do I do any kind of artwork? I don't. I don't do art. I do music, but I don't do art. The guy who used complex numbers for... Oh, for AOC 6. All right, let me write that down. It's in... Is it in the Clojurians? Ellis... Was it Descartes? It sounds like Descartes, honestly. Solution. Complex numbers. Yeah, I play... I'm trained in the trombone, actually, but I haven't played in a long time. But I play guitar, and I dabble in singing. I dabble in guitar. So, I dabble. I'm not a great musician, I would say. I play a little bit of piano. Not sure where to find them, either in Slack or Discord. Okay. But did you find the solution in Slack? Or can you... here. I don't know if you can drop links in the... Advent of code. No, Gaming Sasha, I don't do that level of music. I play... I'll play for my church sometimes. Right, but not... Is this it? Can't tell, but not at all professionally. I used to play trombone with a local orchestra here. That was all volunteer, no audition required. Okay, hang on. Where are we with this? So, right. So we're going over a flattened version of all the points, and we're for each point finding all of its antinodes. This is going to get duplicated. That's okay. A set will take care of that, right? And so this should return the set of all antinodes, assuming that this works. Let's see. Part 1. Well, it returned something. What's the count of that? Some reason this does not feel good. I mean, I just typed out something. Like, I don't have a great understanding of how this works, but it seems like it should, you know? And I just stuck this in here and never tested it, but somehow it's working. So none of this feels great, but you know what we want? We need an onboard question mark. Defin on board for a board B and a point P that does this, right? X and Y. So fill, wait. This is not on board. This is not going to be particularly fast. I'm going to put a star here, for star means inverted indices. So then we want to filter on board, or util on board. Partial. That did not work at all. Huh. Why didn't it work? Oh. Well, no. Or. Yeah, wait, no, and. X. Oh, huh. Yeah, it's got to be between them. But it might include too many. No, count is going to be too many. That can't be equal. It has to be... This is tedious. Oh, well, no, what we can do is make that -1, right? And then that works. Okay. So this just needs to return the count. I think I'm losing our race in paren. I got sidetracked too many times. All right, I got 323. All right, here we go. If inparen is stuck here, that's not good. That's not a good sign. After updating your model, it turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas of the same frequency, regardless of distance. This means that's, well, I'm not going fast and I'm working in Common Lisp and I had a head start. I've got my own code curses. That's fair. Wait, in paren, do we know each other in real life? I feel like we might. I'm remembering your Twitch handle now if we know each other. Yeah, that's what I thought. Long time no see, man. This means that some of the new antinodes will occur at the position of each antenna, unless that antenna is the only one of its frequency. I don't understand what that means. Okay, so these 3 frequency T antennas now create many antinodes. Oh, it happens at regular intervals. I see. Boom, 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 all the way down the grid. Okay. In fact, the 3 T frequency antennas are all exactly in line with 2 antennas, so they're all... What? Hang on, we lost the music. So they're all also antinodes. I don't really understand that. Like, they're in line with two antennas. They make the line between two antennas. I don't understand this at all. But I think I get the point that these are included as antinodes. Okay. All right. I feel like this is a variation on what we just did. Here, I'm just gonna... Let's just get her done. Bum, 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 bum. 2. But the deal is gonna be... like... You can apply this recursively until you run off the board? Right? Like for a given point... Wait... For a given point and a point with the same frequency, you just keep doing this. I think this will be called what? Oh, that's not good. That's not good. I don't know, man. I don't have an excellent idea of what I'm doing here. PXPY. Right, so you can't just do this. This is the... You need to do this and then do it again, and then do it again, and do it again. Using the input from last time. This needs to be an iterate. Right? And you can do it on both sides. Fudge. But doing it on both sides makes it somewhat hard. Right, so probably... concat? I'm running out of symbols. J prime. That's the delta. I prime. J prime. Did you know IJK, like the indices that we use, are the I stands for imaginary? Speaking of imaginary numbers, did you know that? It's from Euler. Euler started using for the complex plane, right? And so things in different dimensions started getting labeled, you know, I. And then we just kind of kept going from there. J and K comes after I. Anyways, factoid. This half of it, right? Hamilton used K? Oh! I feel like, yeah, Euler used it and then Hamilton like made the convention massive, right? Or K for also indices. Yeah, K is really common for just summations. Yeah, quaternions. Quaternions. That's impossible to say. Okay, iterate that starting with PXPY, right? Oh, wait. You gotta do this. Oh, yeah. I don't know. This is looking pretty messy. But then, okay. So yeah, what you gotta do is you gotta say like I prime, J prime. Wait. But da. I think this will work. Some version of that maybe, and then you do the same thing, but subtracting and working from the other side. Probably. Would that? I wonder, I bet you could say next antinode. Next antinode. Right? P prime. P prime. Just do it in reverse, right? P prime. Oh my goodness. P prime. P prime P. P prime P. But I think you want to map second that, because you only ever want well, if those are included, then this would be fine. You don't want both tuples. You have to have both tuples to calculate the next antinode to stay on the line. But then you don't, and then you could take while. Now I already got tripped up take while once. How's it go again? While that returns true. Util onboard, partial util onboard. We need the B, the full B. Gotta have the B. Okay. Let's do. It's not a great way to phrase things like this. Assuming this works at all. I mean, I'm optimizing something that This may not even work. P prime P. Okay. So if I do this and then I say, okay, what are the antinodes for parse T forward of that 2518. Next antinode. Huh? Wrong number args, pass to. Oh. Uh-huh. Ooh. Mistakes were made. It's not terminating. Okay, let's do this. Two, 5, 1, 8. That took a surprising amount of time. Disconnected from remote server. Did I blow the server out? What the? Boy, it did not like something that I did. That has never happened to me before. Okay, Ripple dead? Okay. This is how we're gonna play this one? All right. Back in here. T. Look, let's just do this. Break this down. Next antinode for these guys. Huh? Okay, that did not work. Right? That's not the next antinode. We want 1.8 and then something that's not 1.8. I don't know. Yeah, like that. What if I do it in reverse? Yeah, 2.5 and then something like that way. Right down. I mean, that seems reasonable. Was it 1 at 3.2? 2, 3, yeah, 0, 1, 2. Yeah. This looks good. Okay, so I just had a little oopsie there. I don't know why. Take 10. All right, yeah, these look pretty good. Let's try again. Antinodes of these 2 points. All right, that looks like all of them to me. I mean, I don't know. Okay. I feel like there's a better way to, I mean, this obviously this is all duplicated, right? Like all of this. The only thing I'm doing is switching this, but whatever. BPP prime. We need the antinodes of this is gonna do extra work, but I think we're good. I don't care. B P prime. We no longer have to check on the board because that anti-nodes does that for us. I don't know. Some version of this? Okay, let's see. I don't even know why we have the freak here. Whatever. If it's already in there, then skip it. Okay, so it'll skip some stuff, right? Otherwise, put into there. And this would be, you know, empty list if there are no anti-nodes. I think this is probably good. The anti-nodes of blah. Yeah. Let's do part 2. Bot d t. What's the right answer? That is not the right answer. Huh. Let's not do the count. All right. Wait, it thinks 0, 0 is. Oh, no, 0, 0, 0, 1. Yeah, 0, 1. Okay. Certainly we could speed it up by, you know, putting these in the anti-nodes to start. But how many unique locations would the bounds of the map contain? What about 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? What about 11, 11? Dude, what's not here? How do I get a different number from them? Fine, fine. You forced my hand. Fine, fine. You win. This does anything that's not dot, right? Yeah, okay. So check it. We're gonna parse this, parse that. But then we're gonna get the antennas from that, vowels from that, and into a set. Look, we could probably do mapcat val. Okay, now we have a set of all of them, right? Ah, you're getting the real Clojure goodness now. Now that I get stuck, you get to see all of the ways that you get unstuck. Clojure set difference. The difference, set difference, right, is like subtraction. Did I load Clojure set? Minus what we have for part 2 of this, right? Subtract out the things I know I got. And somehow, okay, like 11.3 did not get got. Or, I don't know, something closer to the origin. 5.1. 1, 2, 3, 4, 5. Wait, 0, 1, 2, 3, 4, 5, 1. All right. So this one should have 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 4, 4. 4, 4. If I do next antinode of 4, 4. 0, 1, 2, 3. 0, 1, 2, 3. 4, 5, 6, 7. 3, 7. Okay, that gives you 2, 10. 0, 1, 2, and 10 is here. That's one of them. And if we swap them, but I'm missing 5-1. Uh-huh. That's because this needs to not be mapped. Wait. No. It says I'm missing 5-1, but doing this 3744 does give me 5-1. Okay, they hate KHI. Whatever. How do I mod actions? No. Oh, yeah, I don't know. Everyone moderate. Okay. Now how do I get rid of this? No. 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 Not that. Okay. Just like go away. I can't see chat anymore. Oh my god. Okay, there it is. Woo! OBS fail, man. All right. All right, back to what I was doing. This does return 5-1 though, right there, right? So if I say anti-nodes for 37 and 44, 5-1 is right there. Why? Why is it not in my set? When I run it. Okay, so we know this will return that, right? Let's make sure it's 3744. Okay. You know what? I think we could actually remove this. We're going over all these points. Okay, I think we skipped points because we found these already somewhere else. Or one of them. Right, this one got found as part of this. This one got found as part of this. So we skipped it. We gotta not skip, I think. There might be another optimization in there that we can use to make up for that fact. But let's see here. Now we have everything. Yes, they are equal. $34 is the correct answer. Okay, only mildly annoying. Now let's see how it runs. This is the I already have the. So we just do in. I would not call the answer pretty, but I think it works, and plenty fast enough. If this is for real, you know it's real, baby. The real deal. Oh. I was gonna say this is so easy, but this one was actually kind of a pain in the butt. It was not particularly easy. All right, let's look at day 8. Day 8. What does this even mean? Yeah. Yeah. No. This makes no sense. This sentence makes no sense. I'm glad I'm not the only one. No shade at all. No shade. Like, the guy who does this is incredible. He does incredible engineering work. The whole thing is done in PHP, which seems impossible to me. Like, super impressed. Everything about this is amazing. That one sentence was a little crazy. All right, as usual, Norman at the top. Yeah. Okay, he did roughly what we did, right? Made that data structure looks like this. Same sort of addition. Iterate. Yep. This is roughly vapid babble. How come we're getting stars? I don't know what causes the stars. Did you say like a curse word? Did you say like a naughty word? Today was easy. Roken Lark. All right, if he says it was so easy, what has he got? Okay, it's pretty concise. Frequency groups. No swearing. Then how'd you get starred? I don't know what this means. Are you just typing star? Are you just trying to like mess with my head? That would be amusing. Wait, how does this work? P in antinodes. P in antinodes too. P. Combos. So, I mean, I guess this is roughly the same what we did with the so's. And then antinodes fun. So antinodes keeps the second of the things on the line. And antinodes 2 how is this not recursive? Oh, this is recursive. Wow. There you go. Okay. This is roughly what we did. I mean, the approach is the same. The phrasing is completely different. Very concise. That's nice. That's nice. Roken Lark. Rocklin Air Kick. All right, Air Doze. Man on the wall. Inbounds. We did one of those. All the pairs. Yeah. I think this is harmonics. Yeah. I think this is a variation on what we did. Much more concise, obviously, but in the same kind of ballpark. Let's see. Is there anything wild? Alex. What do we got? Yep. This is a nice touch. I like this. Oh, you did the same thing, passing in a function to solve. Where'd it go? All right. Some people asking questions. Some timings. All right, we got Felipe, we got Shady. Somebody got hearts. Yeah, this is like variation on the same thing. Yeah, we've seen this before, right? Erdos did that today. This is a variation on the same thing. Some people are much more concise than I am. But their approach is the same. Same thing. Yeah, okay. So this is another one where like that is just kind of one way to do it, and everybody did it more or less the same way. I think yeah, this could definitely be more concise. It could be done better. But y'all know, I'm here. I'm the ape man. I'm here to just get it done. Move on. Let's go. All right. Unless somebody has one I need to look at, that'll be it for me today. I'm gonna do my day job, my regular work. Thanks everybody for stopping by. I will catch you tomorrow at 11. Peace.